Hello. Well, as my subscribers know, I feature all kinds of audio and video equipment on my channel. Oh, hello, Alex.
A neighbour's given me this.
Oh, right. Thank you. Does it work?
Probably not.
Oh,
Here's a remote.
it's got a remote control as well. Well, that's always handy. Thank you, Alex. So what is it? It's a flat panel TV. I would say it's probably about 10 years old. Samsung, complete with remote control. Actually, I have a Samsung monitor in the studio, which is also a TV. So apparently it doesn't work. Let's see what connections we have at the back. Okay, model LE26B450C4W, I think that is. So that's probably a 26-inch viewable area. We've got composite and audio input, a card reader slot thing that nobody uses anymore, RGB via SCART, component in, PC SVGA in, and audio in for that. Antenna, that'll be digital and possibly analog tuner. 2 HDMI ports, so that's more useful. And audio out to drive speakers and optical input. And a USB socket, but it's just for service, so it's not like it can read anything off a USB stick. So, yes, it's not the newest of TVs, is it? But okay, it's better than a kick in the teeth. Let's power it up and see what it does. So I'm using my own power cable because I know that works. There's buttons on the side, and for the purposes of eliminating any problems with remote control, I'll use these. So that's source, menu, volume, channel, and power. So I'll try the power button first when I powered it up from my isolation transformer. There's a couple of, I don't know, sensors there, possibly LEDs or sensors. It's got a very poor screen to cabinet ratio. Great big border around the edge, so that's not a very pretty thing, but let's see what happens when I power it up. No lights or anything. If I press the power button, completely dead. So it's possibly a power supply fault. Let's take it apart and have a look. I'll just remove the stand to make it a bit easier to get onto my workbench. Well, the back came off without quite as much fuss as is the case with some. There, downward-facing speakers. Mainboard there, power supply over here. Let's start with the fuse. If the fuse has blown, there will be a reason for it in all probability. Fuse is fine. In volts mode, let's see if there's anything left on the first mains smoothing capacitor. Even though it's been powered down for some time, there's likely to still be residual voltage if the voltage was getting that far. And seeing 46 volts and falling, so no doubt that that was at 300 something volts earlier on. Got another fuse there, let's check that one. That fuse has failed. That's 250 volt, it says 2 amp, time delay, high rupture current fuse. So we don't just replace that with any old glass fuse. Right, if that's failed, it's likely that, most likely, the chopper transistor's gone short circuit. It says here dated 2009. So with that fuse open circuit, but still a residual voltage on here, it implies that what that fuse is feeding has gone short circuit. I probably need to get the schematics pretty soon, but I could look for a short circuit transistor. I think we'll take the board off, the power supply board, and just look for short circuits. You can see contacts here going out to the high voltage backlight on this older model TV. Now we can work in more comfort on the power supply. Should I set you up to look down on it? I've just been looking at this power supply and I've found something a little odd. This diode here, which is ZM801, and that appears here on the diagram, I'm seeing a dead short across that. Now why would I have a dead short across there? Well, what could be there? It's not like it's got any transformer windings that would be very low impedance and appear as a dead short. It would either be the optocoupler or the Zener diode itself or a capacitor or the IC here. And this controller IC, which is ICE3BR0665J, I've looked that up. I'm no expert on this kind of circuit, but I just cannot see why I'd see a short circuit there. It looks suspiciously wrong. So that would be between pins 2 and 8 of the IC. That's between pins 2 and 8 of the IC. I'm getting a short circuit. I would really like to know which component's providing that short circuit. It's going to be either this capacitor, this Zener, the optocoupler, or the IC. Right. Let's debug that a little bit. If I just open circuit some pins on components, I should be able to find out what the problem is. The components in question then, here's the Zener diode, and this is the IC. It's connected to pin 2 of the IC. So I could open circuit that and this, and also check that capacitor if I can find it. Okay, the capacitor number 801 I think is that tiny little dot here. Okay, so I've open circuited the Zener diode from the pad, and I'll just prove that. And the IC pin from the pad. So now I can work out which device is grounding pin 2. I've not open circuited the capacitor, so I'll start by checking across the capacitor. Nope, that's not the short. Here's the Zener. Nope, so it's going to be the IC. I can't imagine any circumstances in which this pin here should be only a few ohms to ground. Looking at the diagram here, this pin here is just a few ohms to ground. I need to look at the specifications to the IC, but I'm pretty sure that means the IC is defective. Let's see if any other pins are grounded as well. Pin 1, pin 2 is grounded, 3 is grounded, not 4, 5, 6, 7 is not quite grounded, and 8 is ground as it should be. So pins 2 and 3 are both at ground. Pins 2 and 3. Pretty sure that means the IC's failed. The other pin that's almost ground is VCC. Let's check that this diode is in good order. That's DM802, 1M4007. We'll check 802 and 803 when I find them. That's 802. Reverse is good, and 803. I'm getting a diode in reverse on 803. I have to look at the circuit to see if that makes sense. I will check that diode. Just checking diode 803. Let's first check that it's no longer making contact with the pad. Good, it's not. There we are. Diode voltage one way. That's the right way around as well. And the other way, nothing. So it's on the land. We go to the land, yes. So that's the circuit around it. So the diode itself is not at fault. So this IC, which is on the diagram, this one here, I'm going to remove. We have not one but two of the ICs here. ICE3BR0665J LE26B450C4W, but I'm a little bit wary of just fitting them, or fitting one. I need to be very sure that there are no problems on the board. I've changed this for a high rupture current fuse with the same rating. Let's check this capacitor, which should be 22 microfarads. I have remote control operation on this capacitance tester. I don't know if you can see that for glare, but 22 microfarads it is. So I'm trying to work out what in this feedback circuit here or otherwise could have caused the system to blow up. There's a fusible resistor here that I haven't found on the schematic yet, but let's just check that it looks sensible. 0.5 ohms. It says diode here. It says Zener diode, but doesn't give you the voltage rating, which is unhelpful. Number 801. If I had to put a basic component tester across that diode, this might be able to give me the forward voltage drop, or reverse voltage drop I should say. Oh, it says it's two diodes, a normal and 3.86, so I'm guessing it's probably something like 3.8 volt Zener diode. Without taking every component out, we're not going to make a huge amount of progress measuring all these components. Pin 1 of the IC that's removed being in this corner, let's just do resistance tests to ground from each location and let's see if they tie up with what the schematic seems to imply. So what do you think? I think we might have to commit an IC to this. I was debating fitting it in an IC socket, but I don't know, that might upset the conditions. Let's not do that. Okay, so that's the IC fitted the right way round. Let's solder it in. So I've fitted that IC there, and I've inspected it under a microscope, make sure there's no possible problems. At least momentarily. I will refit the back cover. Right, I'm about to switch the TV on, and it could of course just blow up, and I'm a little terrified of this prospect, so I'm going to ask my young son Scott to do the honours for me. So Scott, the master switch is down here on the power supply. This is a isolation transformer.
Okay.
And I'd like you to switch it on, initially just for about a second, and then switch it off again, and we'll listen for any loud bangs. Yeah, 1 second, and we'll listen. Go on in. Right, well we didn't hear a bang.
That's good, I guess.
I guess that's good. So next we'll try switching it on. Now I've got a remote control here, but I also have a remote control monitor over there of the same brand, so that's unfortunate. So I think I will refrain from using the remote and use the buttons on the unit itself.
Should I turn it on then?
When I'm ready to press the button. Let me
Okay.
find the button. Or I try not to switch the other monitor on. I'll try and do it that way. So, okay, I think we're ready. Go. Did anything happen? Don't think it did anything.
It's on, or it should be.
Switch it off again, please. Well, I don't know what to make of that, Scott.
That it's died.
Didn't work. And very briefly, I'm just going to check to see if the fuse that I had replaced is still intact. So, if we don't get a bleep, then we've blown the fuse. The fuse is okay. Well, that's better than last time, I suppose. But why did it not come on? Bottom button is on off. We will plug it in one more time, and I will press the bottom button, and we'll see if anything at all happens. I might ask you to do that switch so I can be ready to switch this off really quickly. Okay, and I'm ready. Go. Nothing. Okay, switch it off. We have failed, Scott. I'm going to make a few measurements just to see if there's any life in the power supply. Got ground on the chassis here. I need to look at the standby 5V line, which is on pin 3 of this connector. But that's a little bit hard to get to, so the best place to get to it, I think, is on a capacitor CM854. So do I have 5V there? I seem to have pulsing 5V there. Did you see that? Pulse, pulse, pulse. I would hazard a guess that the entire power supply is pulsating then. If I was to look at, say, 13V, I can get to that on this connector. What does that look like? Pulsing. Got a line here that's called standby 5.3V, and I'm going to look at it on the oscilloscope when I power the TV up. And it's bouncing around. Let's try to capture that a bit better. The TV's off and it's still bouncing around. Okay, capture it now. Run stop. So it went up to 1, 2, 3, 4, somewhat less than 5V, I think, and then keeps collapsing. Let's do something completely crazy and disconnect the output from the power supply and have a look at the same point. Not sure how the power supply feel about being on no load, but let's have a look. Quite a similar response, but it was ticking over a bit faster. So that's all a bit mysterious, isn't it? We don't still know if the problem is in the power supply or elsewhere in the TV, but I believe it's the power supply. And it seems to be just cycling. I have very little else I can think of to do right now but try the other IC because I ordered 2. It's not going to make a difference, but just on the off chance that that's a faulty component, let's swap it out and see what happens. Okay, so I've replaced the IC again. I'm looking at that 5.3V line. I hope it doesn't go bang and blow the fuse and do anything frightening. Let's switch it on. Exactly the same, it's pulsing. So Scott, look, this voltage line here, standby 5V, is oscillating up and down. It's approaching 5V and then collapses before it gets there. And the trouble is, all the voltage lines everywhere in the circuit seem to be rising, collapsing in a cyclical pattern. So I can't see what's cause and effect. I'm fairly certain the fault is somewhere on here. It's probably just one component somewhere, but I'm having an awful job finding out which one it is. Maybe I'm just not an expert enough on this kind of power supply to know exactly what all the components are trying to do. So it's a little bit frustrating. Now, these whole power supplies do turn up on eBay, and you could say, why don't I just buy one of these on eBay for about £40 or something? And I tell you, the problem is that old TVs with this kind of backlight, especially Samsung ones, the display can go yellow. Have you seen that before on some? I think you might have seen on that one.
Yeah.
The background goes kind of a mucky yellow colour. And that's because these don't have LED backlighting. They've got cold cathode. And they can go out of colour. So it's not worth spending something like £40 on a power supply for this. And then find that you just get a filthy yellow picture out of it anyway. It'd have been great if I'd been able to identify which component has failed here. But right now, I'm a little bit stuck.
Call yourself an engineer, you can't even fix an old telly.
Oh well, look, if somebody has a spare power supply of this type, then they'd like to send me one, that'd be great. I'd love that, and I can have a go at fixing this TV. But unless we have some inspiration, I don't know if I'm going to be able to fix this power supply. Never mind, I will do plenty more audio and video technology in the near future. Bye for now.